thì được. Ghẹo hoài.
Mình nên mặc cái gì đây? Cái này thì hợp cho mùa hè, nhưng mà cái này thì lung linh vào mùa đông.
Cái này màu đỏ, cái này màu xanh.
Ghẹo tay nó ngán.
Chọn màu tiền cái này.
Bình thường của bả là giống như kiểu như mình đi, gọi là mình lên đồ, mình đi chơi đâu rồi đó.
Bữa giờ anh ấy đi xem nhậu. Quảng cáo chiếu rồi. Sao cái bóng anh không đó? Trời, chỉ cái điều mặc cái vest thôi, dùng được mới là khó.
Bé nó chỉnh chu, cái ghẹo nó ngoài.
Chồng nó vui lắm, chị không có gì hết.
Tự nhiên thấy cốt ra một tỉnh đây nè. Bớt số đi.
Bây giờ tới phim nha.
Cái đợt mua macro nhét cái đống Aero Production là cũng không kịp. Muốn kẹo tùy mai mốt ví dụ mà cũng đi đâu á cái chạy lại dọ đồ nó nhăn cái là nó cái chạy về nó thay.
Chị nhớ cái lúc chị mới đi làm á, cũng vậy là đồng phục với là áo sơ mi trắng với váy chân với bút chì, đồng phục. Ngày nào giặt đồ, tối là phải ủi đồ để sáng mai đi làm.
Đó của anh là lâu lắm.
Thì đó em nói cái hố mới đi làm
Mới đúng không? Giờ hết hả chị?
giờ thì đồ tự do.
5 năm gần đây là anh không có để ý đồ. Xong đồ giặt, đồ sấy, đồ mà.
Đồ 9 giờ tới 6 giờ chiều, gì mà ghê.
Không, tại nguyên lớp mà
Okay,
mỗi
I
người.
think we are almost complete, so let's please resume for the afternoon. And as we said at the beginning of the morning, in the afternoon I will start with taking VR models to a data set that combines the federal funds rate series that we have been using in the context of the ARMA arena model illustration in classes. In previous days, we'll augment it with two variables that we think may be core determinants, specifically in the US, after federal funds rate, namely the rate of inflation in the US, as well as the difference between potential output that was produced if physical capital, labor was operating at full capacity, and the actual value of output, while output in form of this measure that also from the outset facilitates thinking of this as a stationary setup, right? In the sense that for output in terms of its level, for sure it would have a deterministic time trend, but partly may also be a unit root series, something that again we'll come back to when we look at VRs with unit roots. But if you look at this difference between potential and actual output, it's basically the cycle of output, right, of the business cycle. So that seems likely a stationary series. The federal funds rate, right, we had differing conclusions from augmented Tiki-Fuller GLS test, but for sure we saw in any case when forecasting in the UNED context, the stationary model works much better than forecasting the federal funds rate. And for the rate of inflation, that's not the price level, the rate of inflation. Right? So it seems not unreasonable to think that this could be a stationary setup, but of course we will only come back to testing all that once we allow for unit roots in the VR, and then in that context also see whether maybe in the VR context the root may not be that relevant to forecasting. But step by step, so this is initially a stationary setup. I'm simply arguing why those three variables reasonably might be in the first piece of work at least considered to be stationary. And so we'll put those three variables into a VR model and estimate that, and then on the basis of that, forecast. So on the course website, in that section on data files for the lectures, you have also a zip file on VAR models. Let me just open it on my laptop, go to that directory where you find that, or might want to install it if you want to execute it in unchanged form. So I have everything in that directory under the root drives data, ATMF25 VR models, and if you download the VR models.zip file from the course website, put it into such a subdirectory on your device, unzip it, you'll get all these files that I have here in this directory above the zip file, including, of course, the do file VR models.do that will be working. Same issue as for all the other such zip files. If you put in a different working directory, please make sure you change the working directory in this data do file to where exactly you have stored the files, and make sure that the data set that we'll be using, called this Fed Funds VAR data, that you put that into your working directory too, so that everything is accessible. So if I go to my VR models do file, at the beginning, again, a good bit of housekeeping, clearing the memory, changing the working directory, creating a log file if you so wish, then importing the data that's in the form of an Excel spreadsheet with 4 variables. We'll for now be using, as indicated in the slides, the federal funds rate, the rate of inflation, and the output gap. The logarithm of actual US real output we'll be using later on, but not in the first step. Then we declare the data to be time series data. Now this is a data set at quarterly frequency, right? Why is that? Even though we have the federal funds rate at monthly frequency, output is not available even in the US on a monthly basis. The highest frequency at which we have original output data from the US statistical offices is the quarterly frequency, and so we have to operate at the quarterly frequency. There's no other choice. Basically, the federal funds rate has been converted to a quarterly frequency, and so that we add the rate of inflation and the output gap at quarterly frequency as well. That means for the portion where we time series set the data in line 35, right? We time series set the data. We now have to adapt our previous command syntax to the quarterly frequency. And so you see that the TS set in the option doesn't use monthly anymore, uses quarterly frequency, 4 observations per year, 4 quarters per year. And then when we adjust the time index to the specific starting point of the sample, you see now the Q, right, where before for the monthly series we had the M. That's the only change. So relatively straightforward changes in the command syntax. When we get to line 37, we should have been able to successfully time set the data set, and then the editor just opens the data editor so that we can have a look at the data. Let's maybe execute those lines up to including line 37 so that we can all be sure that we have the data loaded, and the time series classifier that we wish to work with has been created under time. Right? So from the first quarter of 1970 onwards, we have the federal funds rate, the rate of inflation, the variable that we'll only use later, the log of output. In terms of output, what we use for now, we use this output gap variable between potential and actual output. If you scroll to the bottom, you see actually, and I just downloaded these data a few days ago, they still don't have the rate of inflation on the St. Louis Fed website for the first quarter of 2025. But nonetheless, we'll try to work with forecasting up to and including the first quarter of 2025, because for the federal funds rate, of course, we do have that series available. So for the federal funds rate, we can compare actual to predicted values also for the first quarter of 2025. If you want to forecast inflation, hypothetically, you can just start, of course, in the fourth quarter of 2024, because that is a missing data. Okay, so that's the data set. Let's move ahead in the do file. We declare the in and out of sample period. Right, that of course again now uses the Q notation for quarters rather than the M notation for month that we had before. In order to later compare the forecasts from the VR model also to those from the AR, AMA, ARIMA model, we use the same in and out of sample periods as we have been using in the context of AR, AMA, ARIMA model, just adapted to quarterly frequency. That is the in-sample period ends at the end of 2021, and the out-of-sample period begins at the beginning of 2022. In the next block of commands, we graph the different series. We do all of that in one line graph, right? Here's line on R, pi, y gap. Plots within one graph the variation over all periods in the sample of the federal funds rate, the rate of inflation, and the output gap. So let's have a look at that, right? So we always suggest before you do any serious econometric work, look at the data. Right? That's in times is just as much of a theme as in the cross-sectional setting. And so we have our three series: federal funds rate, rate of inflation, and the output gap. We had already discussed, of course, the federal funds rate series. If it looks a bit different now, it's just because it's converted to quarterly frequency. But this is very much the same data underlying these federal funds rate here at the quarterly frequency as we used in the context of our work on the federal funds rate alone at the monthly frequency. For the rate of inflation in VAT, right, what you now see is illustrated that in the US, following those oil price shocks of the early 70s, early 80s, you had inflation rates peaking at 12.5%, 11%, and so the Federal Reserve would have started, right, its disinflationary policy of bringing up the federal funds rate to that peak that we had seen before in the Univet analysis of the federal funds rate of above 17%. And since then it's been gradually coming down, but not monotonically, but of course with cyclical variations corresponding to business cycles in the US economy. Again, zero lower bound, following the global financial crisis being reached, and zero lower bound being reached following the pandemic. And since we had this, as we saw the very fast hike of the federal funds rate in spring, summer 2022 to a tad bit about 5%. And since then it's coming down a bit, but not much. And I think the latest data beyond the first quarter tell us that inflation in the US at this point is likely increasing again rather than decreasing. And so we'll probably not see much of a cut in the federal funds rate unless something else dramatic happens. Right? That's a good note. It's notable that, for example, in the US now they have this one new bill that's also going to plan the level of government spending in the time ahead under the current presidency, and they have as part of that a projected pretty high deficit. And when financial markets see a very strong budget deficit of the sovereign, of the government, they may respond to that by hiking the risk premium, right, that they charge on bonds that are issued by the government. And so, of course, that per se could even that will see interest rates going up rather than coming down at all. But anyway, that's where we stand right now. Of course, our sample ends at the end of the first quarter. And then finally, the output gap in green. Right, so that you should think of as varying around 0. 0, of course, would mean that actual output is equal to potential output. When you see these peaks in the output gap, those are periods of recessions, right? When the actual output is well below potential output, you have a highly positive value of the output gap, and you see that has happened a few times. But probably, if we were to count quarters, for the majority of quarters, the output gap is negative here, and so then you actually have that the actual output would exceed potential output. How is that possible? If labor works over time, right? Then you can produce more capacity. So that's the output gap, and now from this graph, can you confirm the Taylor rule that the federal funds rate is systematically responding in terms of increases when inflation goes up, in terms of decreases when the output gap does go up? Maybe, for some episodes again, right? You could argue, yes, I see that, how the federal funds rate keeps climbing up as the rate of inflation rises. And you may also, of course, argue that perhaps part, at least, of the zero low bound, for example, in the aftermath of the global financial crisis, was that we had a bottom output, right? That output, of course, was falling in the aftermath of the global financial crisis. think of risk premium soaring up, increasing the cost of credit, decreasing demand as loans were becoming more and more expensive, and firms responding to that decrease in demand but falling out. Right? That's the positive output gap in 2008 and for the years thereafter. And that's when you see the funds rate at that 0.1. Right, so you might also find purely some anecdotes here in the graph, because this is exactly line with the table. But overall, of course, this is the I metric, and so we need to have a more formal set of estimates in terms of how the federal funds rate responds to inflation output gaps, to assess whether or not that is consistent with the table rule. That should suffice in terms of interpreting the graph, the series in the graph. So let's go ahead and bring a VR model to the data. First, lag order selection. The command that's the analog to a VMA SOC is VAR SOC. Right? So lag order selection. In a VR, bring in the names of the variables that are going to enter into your VR. Ordering doesn't matter. You could put inflation first, interest rate second, output gap third, or output gap third, inflation second, interest rate third. That will not affect the results. Because remember, in a VR, in each equation we have the same variables on the right-hand side, all of the lags of the interest rate, all the lags of the output gap, all of the lags of inflation. So this will always select the same lag order. Key point is bring in the variables that you want to bring in, but it doesn't matter in which ordering you can bring them in. So you might just change the ordering on your own and double check that it's going to give you exactly the same lag order selection results. That's as I would get here. In sample, of course, and then quarterly data, so I'll put in a maximum lag of 4. If we had 4 lags, how many parameters does this VR have? 3 variables, at each lag 3 by 3 matrices, therefore 9 parameters times 4 is 36. Plus, Stata by default will add an intercept term, so 3 intercept terms, 39. And the variance towards matrix in a VR with 3 variables had how many distinct parameters? 6, 3 variances, 3 covariances, so we have 45 parameters overall. Now, of course, if we estimated equation by equation, right, it kind of say it's 45 divided by 3, 15. Probably that's still credible, right? But of course, also remember this context. Now we have quarterly observations, not monthly, right? So before we had in excess of 600 observations.
Nice.
We have now, by going to the quarterly frequency, of course, lost a good many observations. Rather than per year having 12 observations, we just have 4. So that's 1/3 of the observations, a bit around 200 or a bit above 200, right? But 15 parameters in the maximum case of a 4th order lag, 200 observations is probably still manageable. But not our preferred one, right? We probably hope there's going to be more parsimonies to gain more degrees of freedom, but if at the maximum we came out with 4, that would still be considered sensible to estimate. For these US data, relatively smooth, that have limited measurement error, 50 parameters in excess of 200 observations. I think that's okay. So let's go ahead, right? But of course, hope once more that the lag of selection will come out with a more parsimonious VAR. We look at the table that has the Akaike criterion, the Schwartz criterion, the asterisk is indicating already at which lag order the criterion is minimized. So for Kaiki, this is the second order VAR. For Schwartz, this is the first order VAR. In this context, if you wanted to go with Schwartz, I'd be not too surprised, right? Because again, you would like to keep the number of parameters limited, and so if you had a first order VR, you have an intercept term for each equation, 3 first legs, inflation, total funds rate in the upper gap, and the variance plus the covariance. So that the 7 parameters should be very manageable with this slightly more than 200 observations. If you added a second leg, we'll add, of course, another 3 branches. That should still be okay, right? So, nonetheless, be extra careful about the number of parameters. I probably still go here with a VR that has I'm a little bit surprised because I ran this UFAN, of course, prior to showing it here. And you can see that the VRs that I look at after this leg or the selection is the second and the third order VR. But I don't think I have bad eyes now, right? The star is at 1 leg for Schwartz, and is at 2 legs for Kaiki. Honestly, I don't know. Maybe I had better eyes when I was doing this preparation. When I was preparing it, right, I said let's look both at the second and third order VR, but that must have meant that at that time in the table it showed me preference for a second order VR under Schwartz and third order VR under Kaiki. Well, now it shows something different, so let's work with that different thing. And so I want to compare now, before I make a final assessment as to whether to work with the first or the second order VR, I want to compare these 2 VRs in terms of characteristics, specifically when we'll do the VR stable in terms of the eigenvalues that will result. Is that going to make any difference whether you say first or second order VR? And then we'll also do a serial correlation test on the residuals of the VR, a so-called VAR LMAR test. This is called Lagrange multiplier test, and whether there's residual serial correlation. We'll see when we see the test statistic. It will be a chi-square test statistic with a null that there's no serial correlation in the discrepancies. So we'll get probability values for that. So let's execute both to make a final decision whether to work with the first or second order VAR. So I'll first bring into active memory the estimation of a first order VAR. Again, our 3 variables, and once more, per se, the ordering doesn't matter. Whether you put the interest rate first or the inflation rate first or the output gap first. The ordering will simply affect which regression result is going to be shown first. That for the interest rate equation, that for the output gap equation, that for the inflation equation. If I put the interest rate first, the federal funds rate equation will be shown first, then the rate of inflation equation, and then the output gap equation. Otherwise, the ordering doesn't matter. In sample, of course, and initially with 1 leg, right? Schwartz suggested 1 leg. So for VR, Stater likes that notation legs. Lowest leg, which of course is always 1, slash highest leg. And if I have only 1 leg, I'll say 1 slash 1, right? That means that's just 1 leg. In the model, when I have a second order VR, I'll say legs 1 slash 2. Lowest leg over 1, highest leg over 2. All right, first the first order VR. So I go back to Stata, right, and now you see first some general information about the VR estimated, including in particular selection criteria at the top, and then also the R squared for each equation. For example, in the VR, and then come those VR estimates. Right, dependent variable R means that is the equation where the federal funds rate is on the left, and the first leg of the federal funds rate, and the first leg of the rate of inflation, the first leg of the output gap plus the intercept term. Then comes the rate of inflation equation on the same regressors and intercept term, and finally the output gap equation, once more the first leg of the federal funds rate, the rate of inflation, and the output gap itself plus the intercept term. Right? Those are all the coefficients that we do estimate. Now let's pick, say, within the federal funds rate equation, that coefficient on lagged inflation. Right? What is the interpretation of that coefficient? It says if inflation was to increase by 1%, we'd have an increase of the federal funds rate rounded by 0.07%. Is that a structural coefficient? Does that have economic limitation, for example, in the context of the Taylor rule, that it's the response of the federal funds rate to inflation? But one thing you need to be very careful about here is, right, this is the lagged rate of inflation. The central bank more likely is to respond to current, perhaps even expected future inflation, but expected future inflation will be a function of current inflation. Right? And in this model, if you interpret this coefficient, it says everything else equal, ceteris paribus, if you had this unit increase in the rate of inflation, the federal funds rate will go up by around 0.07%. Right? Everything else equal means also holding the current rate of inflation constant. That's probably not the thing that's going to happen, though, right? If there was a change in inflation last period, it's probably also going to mean that the current rate of inflation is going to change. And so that we have here this VR, the response to lagged variables, holding everything else constant, meaning also holding constant current variables, means this is probably not structurally interpretable. For example, in the sense of that it was reflected coefficient in the table. And so that goes back to the point that I tried to make in the morning. In general, in a VR, the parameter estimates will not have deep structural interpretation, because they're always going to be what is the response of that specific variable that we look at with respect to a unit or infinitesimal change in one specific regress on the right-hand side. This may be a change in the first leg of one of the variables, holding everything else constant means you hold the current constant. If you look perhaps more obviously at the coefficient on the second leg, if there was a second leg, holding everything else constant, both a leg change one period ago and a current change, right? And so, in particular, because it doesn't give you the opportunity to learn how is that dependent variable going to change if the current value of some other variable does change, we're likely that you can be satisfied just to say holding the current variable constant. I'd say if I held in a completely different context, maybe even more obvious, if I held my current income constant, but my lag income was to increase by 1 unit, that's how I would adjust consumption. That's a very specific question, right? And then you're much more likely to be interested in the more general question, what is your change in consumption if your current income changes? Not if your lag income was to change. right? If you're in the current period, and now you ask, I hold my current income constant, but I changed my lag income, how much would my consumption be different? That's a bit of a weird question, right? So that's not having a deep structural limitation. In general, the set of coefficients from a VR, and that's why we'll not pay much attention to it. And we cannot interpret these coefficients, for example, as being in essence estimated Taylor group coefficient. That would be something different. That wouldn't be running a regression of the federal funds rate on lag values of output, lag values of inflation. But for sure, we would want to do that the minimum. We want to do also current and lag output and inflation. Current values as well. Okay. So now we want to look, right, is first of all, is this a stationary VR that we just estimated? So the VR stable command will give us a graph which plots the eigenvalues of this first order VR, must be 3, right, because we have a first order VR in 3 variables, so must be 3 eigenvalues. It plots these eigenvalues on the complex plane. The real axis on the horizontal axis, the imaginary axis on the vertical axis, and the circle that's in relatively thick black font is the unit. So that is, anything that's inside that circle corresponds to an eigenvalue that is an absolute value less than 1. So all these eigenvalues are within the unit circle. You see, however, we have a pair of complex conjugate eigenvalues, right? Because these 2 eigenvalues have an imaginary value that, unlike the first one, is non-zero. But for us, right, that means we call, if we have complex roots, we can rewrite this as cycles using the polar coordinate representation. So now you see this actually rising in practice, right? It wasn't just a theoretical possibility or theoretical problem set. Now we have complex roots for this first order VR in the federal funds rate without inflation. So complex roots, but for us most important, all the roots are inside. All left. So it's stationary. What about the serial correlation of the residuals? So let's execute this VRLNAR test. And if we do that, we get a table with the probability values. Right? Let's not discuss in detail the construction of this test. It's a chi-square test statistic. So the square for normal, you get the probability values in the last column. And the important part is the null hypothesis is written down at the bottom. The null is that there's no order correlation at lag order 1 and 2. That's what it reports as a fault. So one would be correlation between the current and the first leg of the residual. 2 refers to correlation between the current and the second leg of the residual. So at the first leg, our probability value is tiny, effectively 0. So the probability under the null that you would get a chi-square test statistic of 36.04 or larger is effectively 0. That is, for this first order VR, quite strong evidence, right, that there's zero correlation. And that, of course, would speak everything else equal against the first order VR. Because anything that we'll do afterwards, right, will, for example, in terms of forecasts, be based on the idea that those disturbances of the VR are uncorrelated. That's how we always derive our formulas, right, for the forecast, for the conditional expectation. So we prefer, for sure, everything else equal, to work with a VR that is having silly uncorrelated disturbances. So let's do the check now on the second order VR, whether that would fix this issue. So we'll estimate the second order VR, and right away do the stability check. right? Because we said we are not learning much from the coefficient itself. Anyway, so all the eigenvalues inside in the circle, another stationary VR. Now we have 6 eigenvalues, right? Why? Because you can think of it as we are reducing that second order VR to a yet higher dimensional first order system. Right? And so that's where that second leg is generating additional eigenvalues. So that system in the slides, what I had called this matrix that we were getting when reducing the higher order VR to first order 1 A star. So think of this plot now being the eigenvalues of A star. All of them inside unit circle, stationary, so that's not a distinguishing characteristic, right? That these eigenvalues would cause deviations from stationarity in one or the other case. That's not the case. So let's look at the residence slope coefficient. Under the second order VR, so we'll execute VAR, LN, AR once more. And once we do so, go back into theta. Well, it's going up. Right, this probability value, it's now at 2.0%, I guess, rounded. Say 2.001. If I wanted to make it look a little bit larger, but it's still basically 0.02. But at least, right, at a 1% significance level, we can now not reject anymore the null of low residual formation. And so from that perspective, that seems a preferable model. The second order VR relative to the first order VR, that at a credible significance level, we don't anymore have residual formation. At the first order leg and for the second order leg, for sure, at least at the 1% significance level. Again, right, there's no reason to reject the now no residual formation. So I think from that perspective, the second order VR does do better than the first order VR, and unless we have very strong concern that we can't take up per equation, right, these additional 3 parameters that are in the second order VR that are not in the first order VR, I think we would be tempted to go ahead with a second order VAR. Now, in the do file, I have also a third order legs, right? Again, my eyes must have been bad when I read this table on the leg or the selection criteria. So in the do file, I decided to work with the third order VR. That would make a lot of sense now from what we just discussed, that it's about a VR1 or VR2. So I'm just deleting in subsequent commands the third order leg as well, and change it to a second order leg model. Also for the forecast later on, that I changed the vector leg order from 3 to 2 and forecast on the basis of the VR2 model and the VR3. But I just changed all those 3s to 2. Before we get to the forecast, in line 72 to 78, you have a comparison between estimating the second order VR using the VR command, as we had done in line 68 also. Right? So what would happen if you, just for the sake of curiosity, said, I want to see, is this really or less? Is this really or less what Stata does do of the federal funds rate on the first and the second leg thereof, and the first and the second leg of the rate of inflation, and the first and the second leg of the. Well, let's just do it. Before I tell more about this, right, let's get the OLS parameter estimates also. Going to the main window of Stata, right? We get now the coefficient estimates, the standard errors, t-statistics, probability values. Let's just pick one of them. Say, let's pick the coefficient on the first leg of the federal funds rate, in the federal funds rate equation, of course. Right? This has a probability value for the t-statistic of 0.000 and the t-statistic of 14.40. Now scroll back up to where we estimate the whole VR with a VR command and go to the federal funds rate equation. Look at the coefficient on the first leg of the federal funds rate. What is the, what it calls it now? Z, right? Asymptotically normal, old thing we discussed before in Stata, and it's 14.66, not the same. It's not the same, this 14.66, as the 14.40 that we have in Europe. So you might not think, well, probably it's not right. It's not estimating it by OLS. It's doing something different. But not so. What Stata still does do when it uses the VAR command to estimate the model is it does OLS. But recall in the morning, I said, Stata implicitly always presumes when he estimates the VR that he has lots of observations. Because VRs are pretty parameter hungry, so you need lots of observations, right? And so Stata thinks you have it. And so what Stata does when it uses the VR command, it basically says, let me drop the typical small sample adjustment that we have, for example, in the calculation of the standard errors on the typical OLS. Try to recall the OLS formula for calculating an estimate of the variance of the disturbance term of the regression. And of course, it's the sum of the residuals across all observations, epsilon t hat squared. And by what do we standardize that sum? In the formulas that we typically see for OLS. If we have capital T observations, so we just take 1 over capital T times the sum of the squared residuals, or do we take something else? Go back to your notes on default OLS. We'll typically have 1 over capital T minus the number of parameters. Right? So in the typical textbook formula, 1 over capital T minus K, where K is the number of parameters that we estimate. That's a so-called finite sample adjustment. Based on the reasoning prior to you estimating the variance, you have already estimated K model parameters. Right? So you lose K degrees of freedom. That's a small sample adjustment. What Stata does when it uses the VR command is it drops the K. When it, for example, estimates the standard error of the regression, it just says 1 over capital T times the sum of squares of the residuals. Why? Because it says you have a large sample. You did a VR estimation command, so you must have a large sample. So if into the VR command I brought back in finite sample adjustments, DFK is this adjustment of 1 over capital T in the calculation of the standard error to 1 over capital T minus K. Right? And the second one is another small sample adjustment for the estimates of the variance occurrence matrix. If you put in these two options in the VR command, in line 78, just keep in mind, please, the p-value from the OLS regression. Execute that in Stata. Go again to the Federal funds rate equation. What is now the T statistic under the VR estimate for that first leg of the federal funds rate in the federal funds rate equation? 14.40, exactly like under OLS. And so now you get exactly the same results table as under OLS. Meaning, if you wanted to have your conventional OLS estimates in STATA for VR, tag on these options, EFK and small. Right? Tag on these two options. If you don't tag them on, you get slightly different standard errors, T statistics, probability values for T statistics, and so forth. Right? Anything that depends on the standard errors will come out a bit different than if you were to run a plain request command for OLS. Yeah. The issue is not that it's not in both cases OLS. It is. VR is an OLS estimator, equation by equation. It's just not using the conventional adjustment in calculating the estimates of the standard errors that we use under the request command instead. You can be assured I'd be happy to skip this paragraph if STATA didn't use different conventions to calculate OLS estimates of VRs than it does everywhere else. Now on this count, I think that if we complain to STATA, they will insist that they are right. And say, this is just making sure that you don't fall into the trap of doing your VR for small samples. You shouldn't do it because you'll not have enough observations. I'm not so sure, right, whether that's really going to help people to remember that they should only run the VR if they have a large number of observations. I suspect many people will run the VR command anyway, without carefully checking how many observations they have relative to the parameters that they ask for. But that's the logic in STATA. You get something different under the default VR command than under request. So you would like to have the same, just add on these options. Okay, so now let's go to forecasting. Then we said we selected the second order VR. So again, I'm changing all those third order VRs to second order VRs to fit to what we did do in the model selection. In the first step, I'll first bring back in our VR estimates in the STATA conventional form into active memory, right? So without these options here, big and small. We are the federal funds rate of inflation output gap in sample period with two steps. How do I predict? Pretty similar command, but not the same. So maybe again to add to the confusion. This time, when you calculate out of sample predictions, you use the XP in the option. I think that just yesterday had said the XP we use in the UNIVAD models in sample, but we don't use it out of sample. For the VRs, this is out of sample, use the option XP. So. Secondly, and this one is understandable, right? Because if we forecast the VR now, we have three forecasts. We have a forecast for the federal funds rate, for the rate of inflation, and for the output. Right? So because we need to select the forecast for the federal funds rate, and that's done the equation after. That will tell STATA, I want to forecast the federal funds rate, the dependent variable in that equation that the dependent variable is the federal funds rate. These are the one-step forecasts, and now come the multi-step forecast, and that's quite a bit different in STATA than for UNIVAD models when you look at VRs. It is not this predict with the option dynamic that we have in the UNIVAD setting. This doesn't work for VRs. So what we do is FCAS compute. Think of this as one command. FCAS compute, that's the generic command. Then you say F. F does the following. that when it calculates those forecasts, it's gonna add the letter F in front of the name of the verb. So the forecast of the federal funds rate is going to be called FR, right? Because the name of the federal funds rate is R, and it will put that F in front of it. That's the step. Step 13, then you can probably conjecture how many our sample periods do we have. All of 23, all of 22. All of 24, that's 12, and 1 quarter of 25. So this 13 is 12. Let's just think I have to correct that as well. That's good, right? We have 13 out of sample periods, so that's the step 13. You're going to tell us later how many periods out of sample do you want to forecast. Count the number of out of sample periods. 13. Now I've generated FR, as I said, try to bring it back into my notation in these two files. I do a rename. I rename in the next line FR/SR/F2, and then have it in the conventional name that I'm using for multi-step ahead forecast, just one number up relative to the one-step ahead forecast. When I have two multi-step ahead forecasts, there will be R2, and we'll plot these relative to the actual values. And in line 95 and 96, I want to calculate the root mean squared error that's associated with the one step ahead forecast, so that we can compare that later to the root mean squared errors from the AR, AMA, ARIMA models. How do we do that? Predict, we give a name for this residual, use the residuals option, and need to identify the equation. I think that's relatively intuitive command syntax. And then, of course, we square that. The residual, right, you get the squared error, and later we'll take the root of the squared error, and then we get the root squared error. That's in line, right, with what we have done in the unit. Okay, so let's plot these forecasts, and as an aside, calculate these root mean squared errors, and we'll have them later. In blue, for the 4-day frequency, our federal funds rate out of sample. Now this looks even less steep, right? But that's just the change from monthly to quarterly frequency. We come from the zero lower bound, right, to a tad bit above 5%, and then in the end of the out of sample period, start the Federal Reserve starts to cut back the federal funds rate a tad bit from this 5.25 to a tad bit below 5% by the first quarter of 2025. You see the one step ahead forecasts in red. Those are just like in the univariate models, right? Ups and downs relative to the actual series was more reflecting that every time we calculate a new one step ahead forecast, we update our information set to the latest federal funds rate of inflation outlook here. Keep using all the in-sample parameter estimates, but these are what we know, right? What are these? These are just the realizations of the shock in the federal funds rate inflation in the period. Those deviations relative to the actual series are just what is the deviation of the actual shock in the federal funds rate one step ahead from the mean of the. Nobody is smiling yet. Now it's coming, so slowly, but I'm not yet sure whether you are smiling because I invite you to smile or because you realize, wow. Think back to forecasting the federal funds rate in the univariate models. Where were these forecast? Somewhere down there, right? They had far too little mean reversion. We didn't get to forecast at all multi-step ahead this very significant hike of the federal funds
between mid 2022 and early 2020. This is, as soon as we get into the second quarter of 2023, already starting to over-predict it, right? But I'd say for multi-step ahead forecast, for our outer sample period, I take those. I think that's very promising. Right? And the huge improvement for sure relative to the AR, the ARMA, and the RENA. And so it basically says if we do not just look for our forecast at the end of 2021, at what was the federal funds rate back then? 0. But if we also start to look at the data on the output curve, start to look at the rate of inflation already at the end of 2021, we predict multi-step ahead a pretty strong hike of the federal funds. And even stronger hike, right, in the first couple of quarters out of sample, or maybe the first 3 quarters out of sample, then what happened? So what it says is actually that if you want to narrow down on this small difference here, right, between green and blue, that green, our 1, 2, 3 step ahead forecast all suggests that the federal funds rate would go up stronger than it did. If the Federal Reserve had followed its same historical pattern in the first, second, third quarter of 2022 as it had in our in-sample period, it would have hiked the federal funds rate faster and sooner. That's of course a big debate. Also, still I would say in modern economics right now, did central banks, specifically such as the Federal Reserve, European Central Bank, did they respond to inflation increasing adequately in 2022? Or did they wait too long until they responded? And there's a number of people who say they waited too long. They underestimated the risk of inflation soaring not just for a quarter, but going up in a more persistent manner coming out of the pandemic. And then some people argue, let me say that with all caution, some people argue, and maybe more so even for Europe than for the US, that the central bankers who were at the helm in early 2022, they had forgotten the history of the 70s and the 80s. They were still in their mode, global financial crisis, pandemic. How can we prevent that we get deflation? What unconventional monetary policy could we do so that we don't run into deflationary ranges for the growth rate of prices? And so they said there's no risk that inflation will overshoot. The only risk is that inflation undershoots. Well, if you only see that one side, right, then you are a bit blind on the other side. And when inflation starts to come back up, you may not respond adequately. And I think on that one there's consensus that I'll keep it right to the European Central Bank and the Federal Reserve. I didn't say anything about the State Bank of Vietnam. I just make a statement about the Federal Reserve and about the European Central Bank. I think there's consensus in the profession that they responded too late to the surge in inflation after the pandemic. That helped us for our forecasts, right? Because our forecasts therefore go up earlier, and therefore when the Federal Reserve actually hikes the federal funds rate, it's kind of just dead on.
at least for a few quarters. Of course, that shouldn't be the main judgment in terms of monetary policy, but it helps our forecast, our pseudo forecast. I think again, the consensus is that those the central banks, the Federal Reserve and the European Central Bank, responded too late. Because if you respond too late, then inflation keeps going up and you need yet more drastic hike increases later on. So there's actually a very nice paper, maybe I should put that graph on the course website too, so you've seen it, where somebody collected data on the monetary policy rate hikes after the pandemic, comparing central banks such as the Federal Reserve, the European Central Bank, to central banks in emerging markets. A good number of emerging market economies, and they show that in emerging markets the reaction was much faster than, on average, than in the US. So maybe those central bankers didn't forget the lessons of higher rates of inflation in the past. But of course, to be fair enough, right, they probably also had to be less worried about inflation in 2020-21 than the officials at the Federal Reserve or the European Central Bank. So from that perspective too, right, I mean, even if in the end in your forecast, this is just another side remark responding to questions that we had, even if in the end in your forecast you don't include data all the way back to the 70s or 80s because you think this is not relevant to today anymore, it may be relevant, right? Because even if we weren't that worried about combating inflation in the US anymore in the 2000s as we were in the 70s, 80s, actually the 90s still, that can be a valuable lesson. And it was a valuable lesson in 2020, no doubt. But separate, of course, from that is the question, right? What is the optimal number of observations that you want to use for the forecast? But of course, I do think that it helps us here, right, in terms of making this forecast, in terms of estimating the parameters of the VR, to have that set of oil price shocks in the 70s, 80s, where you did see that the federal funds rate would go up pretty strongly in response to hikes in the rate of inflation. Right? And so that's what it says here too. I see that inflation. And if I was to act like in the 70s and 80s, I would bring up the federal funds rate. Right? So that now is much more visible than, Marcus, than when you asked a few days ago, why should I go back to the 70s and the 80s? Now you can see in this context, when I relate the federal funds rate to the rate of inflation in particular, it's going to be very valuable to go relatively far back. So it's always model specific, right, in the end, because it's exactly how you want to set your in-sample period, which forecast use and so on. But here, I think it's a nice illustration where you see if I go back to the 70s and the 80s and I have the strong response in my in-sample data of the Federal Reserve to inflation, it helps me anticipate what eventually they must realize they have to do. When inflation is surging after the pandemic, they must hike the federal funds. Well, they just did it with a bit of a delay. Again, that was discussion, but interesting. Okay, so that's the VR forecast. In the new file next, it turns to so-called vector correction models, and we need to first discuss the methodology before we do the empirical work on it. So I'd say always from methodology, when possible, good to have a fresh mind. It's 18 past 2 according to that clock here. So I'd say let's start half past. Is that okay? Let's start half past, so we have 90 minutes in the second session, and think for sure we can finish up vector correction models in that time. And I was advised over lunch that you might need readjustment to New Keynesian DSGE models to intertemp optimization based macro models, and so the hint was maybe I should shock you in quotes this afternoon so that you get used to it again, and then when we do all those models in more detail on Thursday and Friday, you'll be less shocked. But we'll see. We'll not rush. We'll make sure that we do our completion of VR vector correction models this afternoon. And let me also say at this point, just to double check that I don't do something unnecessary. I was told that in the advanced fundamentals of macro course, after you did that component from the Blanchard textbook, you would have gone right into a New Keynesian DSGE model with the frictions, with the sticky prices, sticky wages, imperfect competition, and all that. And you didn't take the step of first writing down a so-called real business cycle model, which is such a model without any frictions. So it's perfect competition, fully flexible prices. Is that correct?
No.
So you have never seen a real business cycle model? Yeah, so I'll try to put that in between. That may help for this course per se, because then you'll see better what these New Keynesian DSG models do, but may also be helpful in the end for the preparation. No, you took the exam already, so, but yeah, for the further absorption of the advanced topics in macroeconomics, may help for that. Anyway, let's take the break. Resume at 5:30 so that we have 90 minutes, and then we'll talk about it.